Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. In daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join Plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter Plus, every need of yours will be taken care of and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture. And if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous video I introduced to you the concept of frequency response of an amplifier. In that I showed you the general shape of the frequency response. The general shape of the frequency response was something like this. Okay. There I told you we divide it into 3 regions. One is the low frequency range. Then the second, in which the gain is almost constant, is mid frequency. Then high frequency. Then I told in low frequency range which capacitances we have to consider. We have to consider the external capacitances, which are the coupling capacitor and bypass capacitor. Similarly, when we talk about high frequency range, which capacitances do we have to consider? The diffusion and the transition capacitance. Then I told we have to figure out these cutoff frequencies FL and FH. So I told you FL is basically maximum of the three cutoff frequencies FL1, FL2 and FL3. FL1 was 1 by 2 pi the Thevenin resistance across CC1 into CC1. FL2 was 1 by 2 pi Thevenin resistance across CE into CE. FL3 was 1 by 2 pi Thevenin resistance across CC2 into CC2. We derived that RTH1 was coming out to be RS plus R1 parallel R2 parallel beta RE. Similarly, RTH2 we derived RE parallel capital RE, and RTH3 was RC plus RL. So these all derivations we covered in the last lecture. So I have told you how to analyze the low frequency response of BJT. So in this video our focus will be on the high frequency response. Now if we only draw the high frequency response of BJT without considering the low frequency region, then the response is something like, okay, this is your mid band gain, then the frequency at which the gain becomes 1 by root 2 times is FH, or your cutoff frequency. I told you cutoff frequency is also known as 3 dB frequency, half power frequency. This is your FH. Okay. Now if you see this graph resembles the graph of a low pass filter. That is why the circuit that has been drawn here is an example of passive low pass filter. Why I am calling it passive? Because there is no active component such as an op amp or a BJT. Now if you want to find the transfer function of this circuit, it will be V0 by Vi. We can find out V0 by Vi by voltage division, that is 1 by SC over R plus 1 by SC. So it is similar to 1 by 1 plus SCR. Now if you want to go into gain or frequency domain, you will replace S by j omega. So 1 by 1 plus j omega CR. In that, if you calculate the magnitude of gain, it will come out to be 1 by under root 1 plus omega square R square C square. Okay, that will be the magnitude of gain. Now in this, if you check at omega equal to 0, the magnitude of gain is how much? 1. At omega equal to infinity, the magnitude of gain is how much? It is 0. So that means it is behaving as a low pass filter because gain at low frequency is high, whereas gain at high frequency is low. Now this function can also be written as like this: 1 plus omega by omega h square, where omega h is nothing but 1 by RC. Now see, when omega equal to omega h, what will happen? It will be 1. So gain will be 1 upon root 2. That means omega h is the cutoff frequency. So you can say that the magnitude of gain is 1 over under root 1 by 1 plus omega by omega h square. And then you say that at omega equal to omega h, magnitude of gain is 1 by root 2, that is maximum by root 2. So omega h is cutoff frequency. So if you see the cutoff frequency here also, it is same, it is 1 by RC. That means the method to derive the cutoff frequency will also remain same. We will derive the Thevenin resistance across the capacitor, and then 1 by RC will give us the cutoff frequency. We can write down FH is 1 by 2 pi RC. Okay, that much is clear to you. So in this video, what our focus will be on analyzing the high frequency response and finding the upper cutoff frequency, that is FH, which is also equal to 1 by 2 pi RC. So for an amplifier, if I talk about, I will write AV, that is voltage gain at high frequency, will be equal to maximum gain. Maximum gain is observed in mid frequency region, divided by under root 1 plus omega by omega h square. Now if you write omega equal to 2 pi f, that factor of 2 pi will get cancelled. So 1 plus f over fh whole square. Okay. So that is how the gain will vary in the high frequency region, and based on this analysis we will try and determine the upper cutoff frequency. But the question that comes to mind is, why does the gain reduce at high frequency? As I have told you, at high frequencies we consider the low capacitances of the range picofarad. These low capacitances are also called as parasitic capacitances, which means they are undesired but they are present internally to the BJT. Now, what capacitances are these if I show in the BJT circuit? In BJT, base emitter junction is forward bias. So in a forward bias diode, we define a diffusion capacitance. Then we have a lead capacitance. Then we have a wire capacitance. Okay. Lead capacitance means capacitance of the terminal that is brought out from the BJT. Wire means the wire, copper wire or any other material which is used to connect BJT to other component. Remember, these are two different things. When you buy a BJT, as I showed you in the first lecture itself, the BJT has 3 terminals like this. These are called as leads. Now you will connect wires to these leads in order to connect BJT in a circuit, and that capacitance will be the wire capacitance. So lead capacitance is the capacitance of terminals that are brought out from the BJT. Wire capacitance is the capacitance of the wire used to connect BJT in a circuit. Similarly, between collector and ammeter also we will have lead capacitance, we will have wire capacitance, we will also have the load capacitance. Load capacitance means the capacitance of load connected at the BJT. Now suppose BJT is driving another BJT. Okay, suppose I have connected 2 BJTs. So if BJT is driving another BJT, the input capacitance of the second will work as the output or the load capacitance of the first. Okay. So it means the load capacitance is nothing but the input capacitance of the second stage connected at the output of this BJT, because there can be multiple stages. Now we know base collector junction is reverse bias. That is why between base and collector we will show another capacitance, transition capacitance. Okay. Now this wire and lead capacitance are called as stray capacitances. That is, their location is unknown but they are present. And this CD and CT, these are parasitic capacitances. These are present internally to the BJT. Due to these capacitances, the gain reduces at high frequencies. They will reduce the value of gain. but we will not consider these stray capacitances. We will only consider the internal or the parasitic capacitance. But remember, practically these capacitances are also a part of circuit. Now before going any further, we must study about one network theorem that will help us in the high frequency analysis, that is called as Miller's theorem. Now what is the purpose of Miller's theorem? If any impedance is connected between two ports of the network, that is, I told you BJT is a two-port network. It has two ports, one is the input port and the other is the output port. It is very easy to analyze if input and the output ports are not connected together. The circuit is very simple. But what happens when any impedance is connected in between the input and the output port? The analysis becomes typical. Now to simplify that analysis, we use Miller's theorem, which can resolve that impedance into two impedances, one connected at the input port and the other connected at the output port. So what is the purpose of Miller's theorem? It is used to resolve an impedance connected between two ports into two impedances, one connected at the input port and other connected at the output port. Okay. So let us see how this is done. So if I say that this current is I, so how you will find I? I will flow from high voltage to low voltage, that is V1 minus V2 by Z. Now by KCL, I1 is also I, but I2 is minus I, which means V2 minus V1 by Z. Now when you want to break this Z into two impedances Z1 and Z2, then Z1 is connected only across V1 and Z2 is only connected across V2. So I'll say, suppose V2 by V1 is the voltage gain. Let me call it as AV. This is the voltage gain. So what I can say is I1 is V1 minus AV into V1 by Z, which means V1 1 minus AV over Z, or you can say V1 over Z upon 1 minus AV, or you can say V1 by Z1, which means the impedance when referred to the input port, it will become Z over 1 minus AV, where AV is the voltage gain. Similarly, in the second part, I2 is V2 minus V1. But when you refer it to port 2, when you make Z2 is only connected across V2. So in this expression, I only want V2 and not V1. So I'll write V1 as V2 by AV. So you can say V2 1 minus 1 by AV by Z, or otherwise you can simplify it. You can write it like this: I2 is equal to V2 over Z upon 1 minus 1 by AV, or you can say V2 by Z2. So now if you see, I have done nothing. I have just compared the current in the two circuits, and based on that I have found out the equivalent impedance connected at the input and the output port. So at the output port, what will be the impedance? If I write down Z2, if you want to write down Z2, what will be Z2? Z2 will be Z over 1 minus 1 by AV. Okay. So these are the equivalent impedances when they are referred to the input and the output port. Now this theorem, as I'll show you later on in this video, will be very helpful when we are analyzing the high frequency response of BJT. Similarly, we have another theorem, that is the dual of Miller's theorem. Now see, here again there is an impedance, but it is now lying between two currents, not between two voltages. I want to refer this impedance again separately to port 1 and port 2. For that, I'll first write the KVL equations here. Suppose this voltage is V13, this voltage is V23. I want to apply KVL here. I'll write V1 equal to V13 plus I1 plus I2. The current in impedance Z is I1 plus I2 Z. Now if I say that the current gain of this amplifier is AI minus I2 by I1. Why minus I2 by I1? Because current must enter one of the ports and it must leave the other port. So I2 should be actually leaving, but we have shown it entering. So I am showing a minus sign, minus I2 by I1. So if you want to refer it only here, only at the port 1. So what you will write the equation here? V1 is I1 Z1 plus V13. This is V13. So I only want I1. I don't want I2. So what I'll do? I will replace I2 in terms of I1. AI I1. So you can say V13 plus I1 Z 1 minus AI. If you compare these two equations, you can directly say that Z1 is Z into 1 minus AI. Now similarly, if you apply KVL here, you will say V2 is V23 plus current in impedance Z is I1 plus I2. But here if you apply KVL, this voltage is V23. You will write V2 is, current in Z2 is now only I2. So in this equation I only want I2. I don't want this I1. So what I'll do is, I will replace I1 in terms of I2. I1 is minus I2 by AI plus I2. So you can write it like this, V23 plus I2Z 1 minus 1 by AI. Now compare these two equations. You can directly see that Z2 is Z into 1 minus 1 by AI. Okay. So that is called as the dual of Miller's theorem. Earlier we were dividing by this factor. Now we are multiplying. That means if impedance is connected between the two currents, you have to multiply this factor. But if it is connected between two voltage, you have to divide by this factor. So that is how dual is defined. But this dual will not be used anywhere in our analog electronics. We'll only make use of the Miller's theorem. So Miller's theorem is nothing but a network theorem which helps us in simplifying the analog network. Now, as I told you earlier as well, when we are talking about high frequency, at high frequency, which model is used? We only used hybrid pi model. Now in this model, what modification has been done? We have now introduced capacitances also. See, RB, let me revisit that for you. I told you earlier, RB was base spreading resistance. Okay. I told you this is the resistance of the ohmic contact. Since base area is smallest, this resistance is largest. RB dash E, I told you this is the forward bias resistance of base emitter junction. We can write its value also. RB dash E is beta RE, or you can say HFE by GM, or you can say it is R pi. Okay, that is your RE basically. RB dash E. Now this RB dash C, this was R mu. It represented the early effect. Okay, RB dash C is nothing but R mu. R naught, it was output resistance. It is also due to early effect. Other than this, VB dash E was actually V pi. So this current source is nothing but GM V pi. So I have added two capacitances. CD is your diffusion capacitance. Since base emitter junction is forward bias, we will consider diffusion capacitance for that junction. Collector base is reverse bias, so we will consider junction or transition capacitance for collector base junction. Okay. Now this is base emitter, this is emitter. So between base and emitter diffusion, between base and collector we have transition. Is it fine? So it is nothing but the hybrid pi model that we have studied earlier, but I have now introduced the capacitances. Now this model is also known by a name of a scientist. It is called as Giacomo-Letto model. Okay. This is another name given to the hybrid pi model. Now what I wish to do in this slide, what I wish to try is deriving the parameters of this hybrid pi model in terms of your H model. Okay. But in H model we don't have any capacitances. So let me remove the capacitances and redraw this circuit. So what I'll do? I'll open circuit this capacitance. Why open circuit? These capacitances are very low, so their reactance would be very high. Hence they will be open circuited. Okay. This is R naught. I'll now write it as R mu. I'll write it as R pi RB. Okay, simple notation. Now I want all these parameters in terms of the hybrid parameters or H model. Now in H model what we say is VBE is IB into HIE plus HRE VCE. Then we say IC is HFE IB plus HOE VCE. So what I can say is HIE is nothing but VBE upon IB when VCE equal to 0. VBE upon IB when VCE equal to 0. This is your IB. This is your VBE. This is your VCE. Okay. Now, in this case, if I want to derive HIE, if I want to derive HIE for the circuit that I have drawn, what I have to do is, I have to short circuit VCE. If I short circuit VCE, R0 will go away. R0 will be shorted. The current of this current source will pass through short circuit because current wants to have a path of minimum resistance. Then this R mu gets connected in parallel to R pi Y. See this path like this. It gets connected in parallel to R pi. So what you can say, HIE, which is the equivalent impedance VBE upon IB, will be how much? RB plus R pi parallel R mu. Now we know that R mu is very high in mega ohm. So it is simply RB plus R pi, which means you can write down RB as HIE minus R pi. I told R pi was nothing but beta RE. Okay. So we know the value of R pi. We can calculate RB using the H parameter, that is HIE. So I'll rewrite the equations here. We wrote HIE IB plus HRE VC, HFE IB plus HOE VC. So the next parameter that I'll try and use is your HRE. So how you will find out HRE? HRE is nothing but VBE over VCE when IB is 0. Okay, VBE over VCE when IB is 0. So let me redraw the circuit here. The circuit of Giacoletto model without capacitances. This is your VCE. This is R naught, R mu, R pi, RB. And this voltage is VBE. So we need to keep this IB equal to 0. That means what I can say here is, if this current is I, this current will also be I. Okay. So if we apply KVL here, like this. So what you can say? VCE is I, R mu plus R pi. R mu and R pi will be in parallel. This will be GM V pi. Now V pi is the voltage here. Okay. So basically V pi is how much? VBE, because there is no voltage drop across RB, which is equal to I R pi. So that means if you want to calculate VBE by VCE, that is HRE, it will be R pi over R mu plus R pi. That means if you take the reciprocal, it will be 1 by HRE, and you can find out R mu from here. It will be R pi 1 by HRE minus 1. So that is the value of your early effect resistance R mu. Okay. The last resistance that is remaining, we know R pi, we have computed R mu, we have computed RB, we need R naught. For R naught, what I will do is, I'll make use of this parameter HOE. So I am removing this computation and I'll redo for the next parameter. Okay. So what I am trying to do is, I am trying to relate the hybrid model with the Giacoletto model. So now if I write down HOE, what I'll say, it is IC over VCE when IB is 0. This current is basically IC. So we just now saw what is VCE. VCE was nothing but I into R pi plus R mu. Okay. Even now also IB is 0. So what about IC if you apply KCL? It is VCE by R naught plus GM V pi plus I. I have just applied KCL. Now VC is nothing but I R pi plus R mu over R naught. V pi. How to calculate V pi? V pi is nothing but I into R pi plus I. So if you now take IC by VCE, first let me simplify IC. R pi plus R mu over R naught plus GM R pi plus 1. So now if you take IC by VCE, HOE, take ratio IC by VCE, what it will become? R pi plus R mu over R naught plus GM R pi plus 1 whole divided by R pi plus R mu. So now from here, if you want to calculate R naught, what I'll have to do is, I'll have to simplify this. So I'll do HOE into R pi plus R mu minus GM R pi minus 1 is equal to R pi plus R mu by R naught. So R naught is nothing but R pi plus R mu by HOE R pi plus R mu minus GM R pi minus 1. So that will be the value of your output resistance R0. So in this manner, what I can do actually is I can correlate the parameters of the hybrid equivalent circuit and the hybrid pi model or the Giacoletto model. Okay, but you don't have to memorize these things. These values will be given in the examination. Now let us understand how to find the common emitter short circuit current gain. Short circuit current gain means when output is short circuited. So let me redraw the circuit, then you will understand how we have derived this circuit that I have drawn. The actual circuit was like this. RB, RB dash E, which was R pi. Then the diffusion capacitance CD. Then we had RB dash C, which is R mu. In parallel to this, we had transition capacitance CT. Then we had a current source GM VB dash E or GM V pi. Then we had in parallel to this a resistance R0. And now what I have done is I have short circuited the output. Now once we have short circuited the output, then what happens? Then this R0 is useless. And also one more thing that is happening is that this R mu is coming in parallel with RB dash E. Similarly, this CT is coming in parallel with CD. So that is why where I have drawn this circuit, this resistance RB dash E, this actually is RB dash E parallel R mu, which is approximately RB dash E, because this resistance is very high. Also, we have ignored the value of RB. Base spreading resistance has been ignored. Since this CD and CT are in parallel, this is written here. So this is not CC, this is CT. They are in parallel, so they are directly added. Is it fine? Now I want common emitter short circuit current gain, that is I0 by II. That is, I want to find the current in short circuit divided by the input current. I want this ratio. Okay. Why I want this ratio basically is to find some important parameter that I'll tell you later. So see, from the circuit you can say I0 is minus GM VB dash E. Okay. What about II? II will be the sum of two currents. One is VB dash E by RB dash E. The second is VB dash E over the impedance of capacitance CD plus CT. Okay, 1 by SC. Capacitance is always 1 by SC. Now if you take the ratio I0 over II, VB dash E will get cancelled, minus GM divided by 1 over RB dash E plus 1 over S into CD plus CT. So this will become minus GM, if we take the LCM, SCD plus CT RB dash E over RB dash E plus S CD plus CT. Okay, that is the value that I am getting. Now how to simplify this? Okay, how you can simplify this? You can simplify this by first of all writing CD plus CT equal to C. Okay, that will simplify a lot of effort. So this current gain will be minus GM S C RB dash E by RB dash E plus S C. Is it fine? So now what you have to do in order to reduce it to the standard form, divide this entire expression by SC. So what you can do is, this will be minus GM RB dash E. If we divide it by SC, 1 plus, 1 minute, am I committing some mistake? Because SC will be admittance. How is it getting added up here? Okay. Sorry. This will not be. This is a small mistake that I committed here. Okay. So basically it will be SCD plus CT. Okay. So if that is there, what I'll do is, I will just now substitute that S into CD plus CT will be SC. I am replacing this by C. So take the LCM. It will be 1 plus SC RB dash E. Now we just now saw that the transfer function, of low pass filter was something like 1 by 1 plus SRC. We told that 1 by RC is the cutoff frequency. So here also you can find out the cutoff frequency and you can write it. It is 1 by RB dash E into C. That is your upper cutoff frequency, just by comparing it with the low pass filter that we studied earlier. Now we have to talk about one important parameter, that is the unity gain frequency. So we have derived the current gain minus GM RB dash E over 1 plus SC RB dash E. Now you can go into into J omega. So minus GM RB dash E 1 plus J omega C RB dash E. I told you unity gain frequency is what? The frequency at which gain is 1. So calculate the magnitude of gain. Minus will go away when we take the mod. Divided by under root A square plus B square. Now I want a frequency. I want a frequency at which mod AI is equal to 1. So I'll keep it at 1. GM RB dash E by under root 1 plus omega T C RB dash E whole square. Okay, that will be the relation. Now what I will do is, I will try and simplify by squaring both sides. GM square RB dash E square is 1 plus omega T C RB dash E whole square. Okay. Now if 1 is very small as compared to the term on the right hand side, you can say GM square RB dash E square is omega T square C square RB dash E square. This gets cancelled. So omega T is simply GM by C. Okay. Now this GM, or you can say this C, is nothing but CD plus CT. That is diffusion plus transition capacitance. Remember, this formula is very important from numerical point of view. You will see many questions based on this formula only. That is, it will ask you to find the unity gain frequency. It is simply GM by total capacitance, which is diffusion plus transition. Now let us see, what if we don't short circuit the load but we connect a resistive load RL. Now this is the input port, this is your output port. Now if you see that these two parameters are connected between input and output. And I told you, whenever any impedance is connected between input and output, the analysis is difficult. So what we do? We use Miller's theorem. Why we use Miller's theorem? We use Miller's theorem to resolve that into an input impedance and an output impedance. Now this G means conductance, but we can also show resistance. No need to show conductance. This is CD. Now see, when you resolve this R mu, when R mu will come at the input port, how you will resolve it? It will be R mu divided by 1 minus voltage gain. Okay. But when we talk about capacitance, we saw Z input is Z over 1 minus AV. Z output is Z 1 minus 1 by AV. Now in case of capacitance, Z is 1 by omega C. So what you will write? 1 by omega Ci is 1 by omega C mu 1 minus AV. So you can say Ci is C mu 1 minus AV. C mu, or you can say it is, instead of mu you can write T, transition capacitance. So this capacitance here will be Ct into 1 minus AV. Resistance is divided by that factor, but since impedance of capacitor is reciprocal to the impedance of resistance, or is reciprocal to the capacitance, so this factor gets multiplied. Okay. Then we have the current source GMVB dash E. Then you have to resolve this resistance on the output side. I am showing it up here. It will be R mu divided by 1 minus 1 by AV. Then we have capacitor. If resistance is divided by certain factor, capacitance will be multiplied. Ct 1 minus 1 by AV. I showed you the reason, because reactance of capacitor is reciprocal to the capacitance. Then rest of the resistances R0 and RL. Okay. Now that means I have resolved the circuit into two parts. One is at the input and other is at the output. Now in order to find the cutoff frequency, what you have to do? To find cutoff frequency, you just have to find the resistance across the capacitance. So here if I ask you what is the capacitance at the input, it is diffusion plus transition into 1 minus AV, both are in parallel. Okay. And what about the output capacitance? The output capacitance is simply Ct 1 minus 1 by AV. Okay. Now what you have to do is you have to find resistance across each capacitance in order to find the cutoff frequency. Okay. Are you getting my point? Like in low frequency response, what I told you, we have to find Thevenin resistance across each capacitance. For Thevenin resistance, you will short circuit the supply. So what is the input resistance if I see? It is RB parallel RB dash E parallel R mu over 1 minus AV. What about output resistance? Output resistance means resistance across this capacitance. It is R mu over 1 minus 1 by AV parallel R0 parallel RL. So these are the input and the output resistance. Is my point clear? Now you can find out two cutoff frequencies. One due to input capacitance Cin Rn. Other due to output capacitance 1 by 2 pi C out R out. Okay. Now the question comes, which frequency I have to take? Whether I have to take the input frequency or the output frequency. I told in the low frequency response that we consider maximum, but see here. The upper cutoff frequency represents a response something like this. Suppose this is FH1. Suppose this is FH2. So one frequency is saying it will pass all frequencies below FH1, other is saying below FH2. So we have to take intersection. So which is the intersection? This region is the intersection. That means we have to take the frequency which is smaller of the two. So I'll say FH is minimum of FH1 and FH2. Is my point clear to you guys? So what you have to take is minimum in case of upper cutoff frequency and maximum in case of lower cutoff frequency. Now one thing that we have to understand here is, what is this AV? What is this AV in case of amplifier? AV is the voltage gain without connecting impedance between input and output. That means if you remove this impedance, that is if you remove this R and C, the voltage gain is AV. So you have to use the voltage gain derived without the use of impedance between input and output. So how you will do that? You will remove this impedance, then this will be a simple circuit. Find the voltage gain, and that voltage gain will be used in Miller's theorem. Okay, so is my point clear? We have to use the gain in the Miller's theorem, which is derived by removing the impedance connected between the two ports. So if we summarize what we have covered in this lecture, we have seen that at high frequency, which capacitances we have to consider? CD and CT, and other parasitic capacitance, or you can say other stray capacitances like wire and the lead capacitance. Then we saw the concept of Miller's theorem, in which I told the input impedance is Z over 1 minus AV and the output impedance was Z upon 1 minus 1 by AV. Then we saw dual of Miller's theorem, but that is not important from gate point of view or any other exam. Then we saw common emitter short circuit gain. It was coming out to be minus GM RB dash E over 1 plus SC RB dash E. This C was sum of the two capacitances CD and CT. Then we saw unity gain frequency, which was GM by RB dash E. This RB dash E is nothing but R pi. Okay. And we saw that when load is connected, resistive load is connected, we have to resolve R mu and CT at the input and output, and by use of Miller's theorem, and then we can find the two cutoff frequency, and overall cutoff frequency is minimum of the two cutoff frequency. Okay. But the most important part in this high frequency response is this one. Okay. So in the next video, we will solve some problems based on high frequency and the low frequency response, and you will come to understand that how to apply the concepts that we have learned in the frequency response. So this will be all from this video. Thank you.
I hope all of you have enjoyed the lecture that we were providing, and all of you learned something very, very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very, very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is your, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.